is Dr. Ramu, Professor Head of Computer Science Engineering, Narsimha Engineering College, Hyderabad. Today we are going to start the new subject. The name of the subject is Database Management Systems. So you know that the DBMS plays a vital role in the placements perspective also, and it is a core subject. So if you want to manage the data perfectly, right, the DBMS is the best source. So we have earlier the file system is there, but we are unable to store the data efficiently. To overcome that issue, the solution is database management systems. Today class we are going to see the historical perspective of the DBMS. In today's class we are going to see the brief introduction of DBMS and their importance and historical significance of managing data effectively and transition from the hierarchical to the relational databases. Earlier, so we have a hierarchical navigational systems. The data stored should be in the form of trees. Means, for example, if a folder is there, the folder name is F, right? And the subfolder is there, that is the name is F1, and one more folder is there, the name is F2. For example, here a.txt one file is there, and here also one file is there, a.txt, and we are maintaining the same file here also. The three files are the same content, but if you do some changes in this file, this is not going to reflect here and here, right? The data inconsistency. To overcome this issue, we are going to opt at the database management systems, and also I'll show you the how our file system is stored in the tree structure. See, you just type the keyword is tree, then see our entire data is in the form of trees only, tree structure. Got it? So you just type, open the command prompt, type the keyword is tree. And due to this is an inefficient system and manual efforts are required more. To overcome that, in 1960s, the Charles Babbage is introduced the integrated data store. This is a kind of a database, right? So for that work, he received the Turing Award. This is a top award in the computer science. And next, introduce the relational database model. Currently what you are using the table format. We know that SQL, if you consider the SQL and relational model, all the things what we are using currently is the what developed by the in Eager Court's relational model. The same, both are same, right? Here the data is stored in the form of tables. See, these are the, we'll call it as a rows, and these are the columns. Here each row is called as a record and column is called as a field. For example, if we consider that this is the table, right? Name, age, marks, and address, right? So for each entry of the particular student is called as a record, and this is a name, age, and marks, address is called as a fields. Got it? And for this work also he received the Turing Award in 1981. So we have a tables, but we need to manage the data. Manage the data means how to insert the data and retrieve the data, right? And so any operations we require one language that is called as a structure query language. It was introduced in 1980s during the project of ORB. And the SQL is adapted with the ANSI. and ISO. These two organizations are adopted the SQL as a standardization. And these are the Oracle and Sybase and Microsoft SQL Server, the user-friendly what it is called DBMS products, right? You are going to manage the data effectively. Got it? And followed by the object-oriented DBMS in 1990s. Why? So already you have a DBMS, I mean relational model. Using the relational model, you are going to manage the text data. But if you want to manage the images and videos and audio files, the relational database model doesn't work for such kind of data. To overcome that issue, they introduced the one more model, it's the object-oriented DBMS in 1990s. The main purpose of this model is designed to handle the complex data structures like multimedia and popular in the academic and research, because if you do any research, like you can take any kind of research, we need to manage the data, I mean images, right, and videos and audio. So many data sets are there. The data sets, the data is in the different formats. How to manage and how to work with all kind of data, right? For that kind of data, the object-oriented DBMS plays a vital role and is a limited commercial application, and this is a Microsoft Access introduced in the 1991, right? Microsoft, what you are currently using, the Microsoft Access is a personal DBMS displaced other than personal DBMS products, right? This is not a DBMS product. This is on par with the DBMS. And the integration of XML for the web, XML, extensible markup language, right? To accessing the data efficiently, right? The XML you're going to use to manage the data. And this XML is also applied in the DBMS products. And this is the data processing for the fast accessing of a data. And vendor started the integrated XML into the DBMS products for the better results and efficiency. XML roles enhancing the web applications, right? In 1995, Java was introduced, and this is the first Java is web browser is hard Java, right? From there, we started using the internet effectively. From there, the 1997, they introduced the XML, right, to processing the data. See, HTML. The purpose of HTML is to design the web page. Coming to the XML. XML is for the data processing. Data processing. This is the main difference of these two. And web and cloud computing. So cloud computing is also called as internet computing. Internet computing. There is a huge data is there to control all this data, to what it is called, to manage the huge data. We require the highly computing machines, right? So through these, we are going to manage the not only structured data, unstructured data is also there. That is called as a NoSQL databases. The example is MongoDB. MongoDB is an example of the NoSQL data, and Cassandra. These are the two databases, right? We are going to manage the NoSQL, right? So the cloud-based DBMS is called as a AWS, Amazon Web Services, Google Cloud, and Microsoft Azure, right? These are the some cloud computing databases which are using currently. And modern DBMS trends, the main purpose is to the scalability and the performance. The modern DBMS and the focus on supporting the cloud native applications, right? The popular systems, Oracle. So we know that currently we are using Oracle and Microsoft SQL Server, MySQL, okay, PostgreSQL and MongoDB. This is the NoSQL. right? NoSQL. These are the systems. In the summary, evaluation driven by the innovation to need and the impact of the industries from the government to the e-commerce and the future trends, AI integration, automation and the edge computing. See, among these lecture, right, you just understand the how the evolution started from the file systems to the current system, right? Here no need to worry about the this is the history of the DBMS, right? Only you need to understand how the evolution started, right? So integrated database systems and follow the relational database systems, followed by how to manage the relational database system using the SQL, and followed by object oriented object oriented model, object oriented database model to manage the multimedia, and for the fast processing we introduce the XML, right? The followed with the cloud computing. Got it? All these are to manage the data efficiently. Got it? And the next class we are going to see the difference between the file system and the DBMS. Thank you.